Hey everyone, how's it going? Welcome to Munro Live, welcome to the channel. My name's Scott Hoffman, and I'm gonna spend some time today going through the Rivian R1T electric drive units. And as you can see on the table, that's a lot of stuff. Don't be scared though. We're gonna break it down, kind of go through some of the different elements. A lot to talk about, but we'll break it down in the constituent elements. We'll spend some time talking about what the parts are, what they do in the vehicle, some interesting findings, highlighting unique features, comparing to some other competitors, and ultimately wrapping it up with a nice conclusion. So with that, let's start with a little bit of high-level context. So the Rivian R1T, it has 4 electric motors, right? So that is something that is competitively unique. There's plenty of EVs out there on the road with 1 electric motor, plenty with 2. We know the Plaid has 3 now, but as far as production EVs that are being built at scale with 4 motors, Rivian is alone in that regard. And we know that they have chosen to package those 4 electric motors into 2 dual motor drive units. So 1 in the front and 1 in the rear. What you're seeing here, this sort of symmetrical looking unit, consists of the electric drive unit from the rear, and we also have the front over here. So we'll get into the specifics of these, but at a high level, you can just think that on these, you have your electric motors on the outboard side. So 1 here, and you have a Geartrain here, a Geartrain here, and then you have an inverter that goes on the top side. And that's what lives in those aluminum housings that you see right there. And we'll put those up there. We'll talk about what they do, why they're important. But just for context, again, high level on this vehicle. So if you looked at these 2 units, you'd think, okay, they look pretty similar. They're not identical, and we'll get into that more in a little bit. But Rivian claims that this vehicle in total is capable of about 835 horsepower, and they say that 415 horsepower of that comes from the front unit, which is this one right here, sorry. So 415 horsepower, 309 kilowatts coming from this unit, and then 420 horsepower and 310 kilowatts coming from this unit. So from a power perspective, almost dead even. They're saying that they're getting slightly more out of the rear, but not enough to really write home about. We'll get into that more in a little bit. But otherwise, you can see like the design strategy for these is pretty similar, the way that they package them. And at a high level, there's one thing over here, we'll circle back into it in a little bit, but when you think about what a dual motor drive unit looks like and how other people have done it, there's not a ton of executions, but we have the case from the Tesla Model S Plaid dual motor drive unit that was in the rear. We have that here, and you can see it has that same basic sort of almost triangular configuration where you've got 2 Geartrains in the middle, electric motors outboard. They chose to package their inverters on the back side instead of the top. We'll talk more about that in a little bit and why you might do that. But you can see spatially kind of oriented in a similar way. This is a much bigger unit. That one's a little smaller. But yeah, we'll get into the specifics here. So when we talk electric motors in the EV industry, terminology that you'll hear people use is called a 3-in-1 strategy or a 3-in-1 drive unit. And what that means, those 3 constituent elements are the electric motor, the Geartrain, and the inverter. So most people, their electric drive modules consist of those 3 things. When you start talking about a dual motor drive unit, you're talking about either a 6-in-1 or potentially a 5-in-1 unit. So the Tesla one I would say is more like a 6-in-1 because it has 2 electric motors, 2 separate Geartrains, and 2 separate inverters. What Rivian chose to do was have the 2 electric motors, 2 Geartrains, and then a single inverter that sits atop and services both units. So I would probably call this a 5-in-1 execution. And again, sort of those, so motor, Geartrain, inverter, those are kind of the 3 base elements of this, and we're going to go through those one at a time here and talk about what Rivian chose to do and what's unique about them. So let's start first with the electric motor. Now, inside of any rotary electric motor, you're going to have 2 kind of key elements. One thing is what's stationary around the perimeter, and that's called the stator. So that's what these guys look like. Essentially, within these housings, you have this element sits stationary. Then you've got a rotor, which is what's right here. And as the name might imply, that is what rotates. So this lives inside of here. And the way that an electric motor works, essentially, you've got 2 magnetic fields, one that's rotating in this stator and one that's created by the magnets in this rotor. And when the inverter tells this thing what to do, it creates a rotating electric field, and that gets this electric rotor to spin within there. And that's what then turns the wheels. So again, in this vehicle, you've got 4 electric motors, 2 in each of these gearboxes. Looking at this one here, let's start with the rotor. So I'm going to bring this over and set it next to rotors from a couple of other competitive vehicles, and we'll take a look. I'm just going to set it on the corner of the table here. All right. So again, this comes from the Rivian. We've got that in the center. And the other parts that I have here that I'm going to draw a reference to are from the Mustang Mach-E and from the Tesla Model S Plaid. So something that's a little bit unique on this one is the way that they are securing the magnets inside of this rotor. If you take a look at these features here, you can see what looks like sort of black caps on there. And what that actually is an injection molded plastic. Well, it's a section of injection molded plastic that's basically being used to secure those magnets onto these rotor laminates. That is something that we've never seen in another EV before. Typically, people will either epoxy those in place or they will use mechanical staking or wrapping. So to illustrate that, if I were to show here, you can see, so this is from the Mach-E. This is the laminate stack. These are the magnets. You can see there's like what looks like almost glue, and that's a type of epoxy that's used to seat these magnets in here and secure those. Kind of a messy process to apply that. Difficult to get that to flow in and be perfectly distributed through there. So again, it's a rotary component, so balance is important. So that has some challenges. Mechanical staking adds a little cost in the components in terms of needing to add those features. Tesla chooses to wrap this in a carbon sleeve to help retain magnets. What's clever and unique about this one is that they're using an overmolding process whereby they get this assembly complete, they set it in a tool, and then molten injection molded plastic is going to get injected into this under high pressure. That's going to fill those voids, and then that's going to cure and make it essentially a clean, neat, immovable way to hold those magnets with a pretty lightweight material that doesn't have any adverse electromagnetic interference with the other fields that are going on in the motor. So that was one of the unique things about this rotor. The other thing that was a little bit unique is how they are actually holding this rotor shaft to the laminates. So typically, folks will have what's called a keyway, where in the rotor shaft, you're going to machine a section in here, and then in the corresponding laminates, you're going to have these little features that are stamped in that make it so that it slides on into that keyway and is held in place. So you can see you've got like a little rectangular profile there, and then one that matches it in here. So as that slides on, it's going to hold it. But this, the machining of that, has to be very precise and is something that is definitely going to add some cost to go, add that, perform that step. Tesla's rotor assembly here, you can see very similar. It's got a machined keyway. It's got features on the laminates that lock into there. What we saw on the Rivian setup that was pretty interesting, and this rotor assembly is fully assembled. I'm going to come back to one here that's been pulled apart. So you'll notice that if we look at this, there is no sort of keyway feature in here in this laminate stack. What they actually have are very, it's hard to notice at a glance, but they've got mechanical teeth in there that are actually in a pattern that's slightly offset. It goes for 6 laminates and then it repeats. So it creates essentially these mechanical grabbers, and then that is going to create friction that grabs onto a surface, which if you look at this and I spin it, you can see there's no keyway on here. So kind of unique, kind of interesting. That's going to simplify their alignment process when that goes in there. It was difficult to press it off because it's a really tight fit when it's on there, but they got rid of the machining of the keyways, but they had to modify what their laminate looks like a little bit and essentially add those tooth features to make it so that those will grip onto here and provide an interference fit. Appears to be working for them, kind of clever, definitely probably simplifies their alignment, saves them a little time, saves them a little money there. So a couple of interesting things going on with the rotor. Now I do want to point out that in these drive units, although the whole unit is something that's being integrated and packaged by Rivian, if we pan over to here for just a moment, I do want to point out, you can see on the stator and the rotor assemblies, that says Bosch. So Bosch, huge tier 1 supplier, they do a lot of different things in vehicles. But something that's important to note is although Rivian is designing these units, their electric motors is part of this that they are not doing in-house. So although we saw some clever things on the rotor, it would be appropriate to give some of the kudos to Bosch there, because the electric motor components actually came from them. And I do just want to comment on that. So it might sound odd to think that, oh man, they're getting the electric motor from someone else. This is an EV company, like shouldn't they be doing that in-house? But I would just note that competitively speaking in industry, that's actually been quite typical. Lucid and Tesla are actually kind of a little bit on an island in the sense that they, right from the get-go, have been doing in-house motors. When we look at other OEMs, many of them started with electric motors that were purchased from other companies, like a Bosch, like an American Axle. And what that does for them is it allows them to shorten their development time and accelerate the speed with which they can get vehicles on the road. But I will say that that is a trend that we suspect will probably change and that we are already starting to see change. So Rivian, although they have the Bosch electric motors in here, we know that they're already talking about their development of in-house motors. I watched a video the other day where they were talking about their Enduro motor unit that they're working on for their single drive unit applications. And they're saying that that unit with a single motor is going to be able to match the output of one of these dual motor units. So we see Rivian going in that direction. We've seen Ford start to make that transition. So I would suspect that although we're going to talk about what we're seeing here and what's unique, the electric motors within the Rivian trucks, probably within the next few years, we're going to see those start to change. And that's important because conventionally speaking, OEMs really have two main responsibilities. You've got your body, so this kind of stuff, and your exterior, and then you've got your powertrain. And those are important because when someone thinks of your company, right, what does the vehicle look like, and then how does it perform? And especially with powertrain, that's kind of where you get your reputation, right? So that is, why someone might buy a Toyota or a Honda because they want a bulletproof, super reliable engine, or why someone might want a Stellantis vehicle because it's got a big old Hemi, right? That is one of the areas where you can really create competitive advantage in powertrain components. And so again, we see Rivian on their way there. A little bit of this was off the shelf, but we can expect that probably these motors are going to be Rivian ones before long. But for now, they're still relying on Bosch. All right, so we've talked about the rotor assembly. Let's quickly touch on the stator. So again, this, as the name implies, stator, it is the static element within which the rotor turns. So on this vehicle, you have 1, 2, 3, 4 stators. We've got a couple of them pulled out here. With these, nothing really crazy earth-shattering about what we're seeing. They are using only ethylene glycol or coolant to cool the stators. So Tesla would use pressurized oil cooling inside. This is just a little bit of a different strategy. The motors themselves are smaller in this vehicle, so not crazy to see that that's different. We did notice that between the front and the rear, though, this is one thing I did want to point out when we're talking about the electric motors. Although the output and the reported numbers from what Rivian said about these units is that one is 309 kilowatts and one is 310, the actual difference in the width or length of the stator and the rotor in the front and the rear, in the rear it's about 15% wider, right? So it has more laminates, the conductor bars, the copper is longer, and it's got more length in magnets. And ostensibly, all else held equal, we would expect that a larger rotor with more magnets and a stator assembly with more length and copper and conductor bars should put out more power. So this is a big if, but it would seem as though if those are rated the same and the one's bigger, perhaps Rivian's sitting on some untapped power that maybe with an over-the-air update or calibration things in the future, they could unlock a little bit more power coming out of the rear unit. So we'll have to ask RJ about that one. I don't really know, but it would seem that there is definitely some unused capacity existing within the rear gearbox at this point. All right, so we talked about basically the electric motor assembly, some of the interesting features there. Let's now talk about the Geartrain, or basically the way that power is transferred from that motor into the internals. So I'm going to disassemble this a little bit because I think we probably want to see what's inside. So I'm going to remove one of the side housings here. I'm going to remove the other, and I'm going to remove this center casting. I don't know if we can get around here with the camera to see some of the insides, but essentially what you're looking at here is pretty typical of what you'd see inside of an electric motor gearbox. You've got your rotor and stator over here. On the end of that rotor shaft is a gear. That's going to go through a set of reduction gears that's going to get us to a point where we have our final drive gear, and our half shafts are going to go in this axis and basically go out to the wheels, right? So they're taking the revolutions from the motor here and the power that's generating, stepping it down to a 12.6 to 1 gear ratio, and that's what's going out to your tires. So I would note that although we said that there were differences in the rotor and stator width on the vehicle, or from the front to the rear drive unit here, what is also worth noting is that the gearboxes themselves from front to rear are totally identical as far as the internals. So the gears, the helix angles, the drive ratios, the tooth count, everything, front and rear, we could take these parts and swap them around and they're basically the same. Everything would mate up. So kudos to Rivian for reusing some of the same parts there. We like to see that, benefiting from economies of scale. Looking at the way that this is laid out, again, not super different from what we saw with the Tesla one, where it was kind of this triangular mirrored assembly. But what was a little bit unique, if we look inside here, is the way that they chose to provide the bearing support for the final drive gears. So looking at this, they've got a center casting, and if I put this in place, what you're going to see is that bearing, that roller bearing, sits on this inside surface, and you've got an exposed conical bearing here. That receives this gear from the other side of the gearbox. Whoops, I had that backward. So although they have two totally independent gear trains and they're not linked by a differential and there's nothing mechanically that's tying the sides together from one to the other, they do share essentially an intermediate shaft, and they have this center bearing support that's nested into the center casting in a pretty clever way. And yeah, this is going to probably pop out. The reason that we mention this, this is kind of clever here in the sense that they've got a very narrow center casting that's providing the vertical support for both output shafts. And if I were to just compare this, I'm going to let that fall. So we'll take this one. You look at that, it's probably about maybe 1.25 inches thick. If I take that and compare that to the Tesla Model S Plaid intermediate section here, you can see that that's quite a bit thinner, right? This versus that. I would say it's about probably 1/3 of the width. And the reason that they basically were able to do that is instead of the Tesla where they had machined pockets on either side that accepted the gears, this one uses a common gear to hold, and then they're able to narrow this package and provide the support they need in the center section. So kind of clever there. Like what they're doing. It's definitely a compact unit, but they're also getting good vertical durability out of that center casting. Beyond that, the gear train here, I'm going to set this here, wasn't crazy. You know, the bearing's pretty conventional, a series of conical bearings coupled with just your more typical cylindrical bearings that go in there. You know, from what we could tell, pretty conventional stuff. This gearbox is cooled with what they would call splash cooling. So that just essentially means it's more of a passive setup. So some of the Tesla units have a pressurized oil system where you've got various jets and passages where you're pushing oil through and causing that to fall on certain components. Within these gear trains, basically you've got a bath of oil, and the only thing that's moving it around is motion of the vehicle and then the moving of the internals, and it sort of splashes around and is just picked up by the gear set rather than pushed to different places. Not an inherently good or bad strategy. It is a less costly strategy. It's something that if it's working for them, kudos to them. It definitely saves some cost. But yeah, pretty simple cooling setup there. And I would also point out that, so you've got this separation in the gearbox whereby the gear train has oil in it, and then you've got coolant going through the electric motor assembly, passing through jackets in the stator that comes from the inverter. But essentially, at this point, there is no crossover of fluids from one to the other. You don't have any heat exchangers between the ethylene glycol and the oil. They're essentially, this routes back, that stays in its area, and so you don't have any thermal transfer between oil and ethylene glycol. And in that sense, a little bit different strategy than Tesla there. So we've covered the electric motors, we've covered the gear train. Now the other sort of piece of that 3-in-1 puzzle that we want to make sure we touch on, and that no discussion of electric motors is complete without, is the inverter. So these kind of big aluminum housings that we see, there's one from the front, one from the rear. We're going to zoom in and take a look at these components and explain what they do. But at a high level, an inverter is essentially necessary because in your electric battery, you've got high voltage DC power. These are AC motors. So the signal, the power that's stored in your battery, that's that DC power, needs to be inverted to a 3-phase AC signal to then send to your electric motors. So what you've got with an inverter housing, just put this on here. So this puppy's closed. If I open it up, there are several important components, and I just want to point out what those are and kind of what they do. So the most important thing in an inverter is what's called your power switching components. So in this case, you've got something called a MOSFET, M-O-S-F-E-T, and that is a long and silly acronym for something that stands for metal oxide semiconductor field effect transistor. Glad I remembered that one. But essentially, it's a long and confusing name, but what that is doing is handling the power, the switching of power from that DC to that 3-phase AC. And these are some of the hottest components in an EV, and we can, take a look at that. This is supplied by a company called Danfoss. You'll see some form of power switching components in nearly any EV, but because these have so much heat that's generated in them as they're going through that process, these often come first in the stack up of cooling that you're going to do in an electric motor assembly. So what we see here on the bottom of this power switching component, this MOSFET, is what's called a tortuous path heat sink. And so you can look at it, looks like it's a little maze, right? And basically what this does, coolant is going to pass by this and it's going to force it to go through these fins. And as it does that and it makes that contact, it's going to wick heat out of this assembly. So the way that these are packaged in here, essentially you've got a machined aluminum face that's going to go down and seal into this assembly. Sorry, I had that sideways. You can see we've got a rubber gasket. And then on the underside of this here, coolant is coming in through this port. And you can see there's little slots that are allowing coolant to essentially bathe that tortuous path. So for each of these electric motors, you have 1, 2, 3 MOSFETs that are the power switching components. So you got 3 on this side. And then if we pan back a little, if I were to unpack this, and we're just showing some of the different elements in here. Again, you have another 3 here, same components. Those are basically the ones that are handling the power conversion for the other electric motors. So kind of clever, you're seeing what they're doing here is this is one housing, but it has basically the separate accommodations for the 2 different electric motors. Separate banks of power switching components, but kind of cool, they're sharing a capacitor assembly. So this is a big capacitive bank essentially that's tied to both sets of power switching components, and you've got like a master PCBA here that is also servicing the whole unit. So this is an area where they're a little bit different than Tesla in terms of their strategy, right? They've got one sort of dual purpose inverter that goes and sits atop and services both units. Basically the way this mounts on perches, you can see on the underside there, you've got this feature, lines up on the top there. And if we had the other side of this installed, you'd see, okay, it spans the full width and basically makes this nice triangulated assembly. Now I want to compare and contrast this to what we saw on the Model S Plaid. Then we'll talk about why you might do one versus the other. So on the Plaid assembly, instead of having the inverter up top, they had it on the rear and they had 2 completely separate inverters. We have one of those down here. All right, inverter assembly, Model S Plaid. So if I were to come to the back here, you'd see that this kind of unique shape would fit in nicely there. And that is, if you've followed the channel for any amount of time or seen any Tesla motors, exactly what the inverter looks like on a Model 3 or a Model Y or a Model X. And so although I would say that in the spirit of integration, what Rivian did here was clever in that they have a single inverter housing that's accommodating both, Tesla chose to keep 2 separate ones, not because it was maybe the most integrated strategy, but because it allows them to benefit from the economies of scale, right? This is an inverter that they're already using for all of their other volumes. So for them, although they might have been able to do something more like Rivian and make sort of one mega dual inverter, they just kept it as 2 single ones because they've already got the volume, they've already got them in production, and they didn't want to retool it separately. So I would say that the 2 companies use different strategies, but I can understand why Tesla did what they did. And for Rivian, you know, something I'll be interested to see, we know with this truck, they have versions that are going to have fewer motors. So the challenge there is if you've made this inverter that now accommodates a dual motor setup or a dual motor drive unit, what is that going to mean if you drop to a single electric motor? It means you have to make a whole new inverter assembly. Maybe not great. So just something to keep in mind there. There is, as we kind of round out the discussion on the gearboxes, so we've talked about the electric motors, we've talked about the Geartrain, we've talked about the inverters. The last thing I wanted to touch on that is kind of an interesting feature, and actually a first for us in terms of seeing this on EVs, is this component right here, which is an axle disconnect mechanism. So this is not the first time we've seen a feature like this on any vehicle, but in the EV space, relatively uncommon. So what is this? What does this do? Let me first show you basically where it mounts. So on the gearbox, this goes onto the outside. Basically, this is the output, and you would have a half shaft, or essentially your drive shaft that goes to the wheels that plugs into here and then goes out to what's connected to the road. This is a half shaft here for anyone who's curious. So essentially that plugs in, and again, that goes out to your wheel. So an axle disconnect, what that does is it allows you to essentially decouple those half shafts from the electric motor, from the gearbox. And you might say, why would we want to do that? The reason to do that in an EV and in an ICE vehicle is all about efficiency. So in the Rivian R1T and presumably the R1S, they have what's called conserve mode. If a driver selects that mode, what the vehicle does, it does three things kind of simultaneously. First, it lowers the ride height to improve the aerodynamics and essentially, you know, get rid of turbulence at the front end, make it a little more streamlined. The second thing that it does is it scales back the output of the HVAC system. We've seen that in other EVs. The last thing that it does is it uses this rear axle disconnect, or RAD if you want an acronym, to physically decouple the rear drive line and basically make it a two-wheel drive vehicle. So what that does for them is it's all about range extension or range preservation, right? If you can remove that extra set of two motors and all the rolling resistance to the tires and the drive shafts when you don't need it, that is going to allow you to extend that range a little bit more. So this unit's fully assembled. I'm going to grab a couple of the parts here on the table or just kind of show you. So here's the housing that we're seeing. This is just kind of a cast aluminum shell, if you will. Inside, you've got a couple of shafts, one that interfaces with the drive shaft right here. So the spline feature on the drive shaft would go into there. You've got another side that connects to the output of the gearbox. And then kind of the critical bits, you've got sort of a clutch housing. And then you've got something that's called a dog clutch that has little flipper plates in it. These guys right here. Those drop in. And basically you've got an electromagnetically actuated ring here that when you supply power to it, it flips these guys and those lock into these features here. And what that's going to do is it's going to basically either make it so you're connected or you're not, and it's going to do it in the blink of an eye. This unit is supplied by a company called Means, which is a subsidiary of the Amstead Group. It is supposedly developed specifically for EVs in the sense that it allows a little bit more efficiency, and critically, it's really, we'll say, light on the power that it draws. So it only consumes power at the moment that you actuate it. So this is a normally closed system. Essentially, the default state for the vehicle is that you have power to all four wheels, but on demand, when you need it, this gets electrically actuated, that clutch separates, and then in that 20 milliseconds, basically you've gone from a four-wheel drive to a two-wheel drive vehicle. We've seen it in the ICE space. GM, Stellantis have done it. It's helped them improve the fuel efficiency of their vehicles. Fun to see it work its way into an EV. Certainly Rivian spent the money to add this feature, right? And because they have two independent motors on the rear drive unit, that means that they have one on this side and they have the one on this side. So there's definitely some expense there, but this is a good example of another lever that EV OEMs have to potentially pull that allows them to play with that range and attack that topic of range anxiety that we all know is so prevalent, right? So it'll be interesting to see whether or not other folks choose to adapt axle disconnects in their all-wheel drive or four-wheel drive EVs. We'll definitely be keeping an eye on that, but kudos to Rivian for trying something a little different here. I'm sure if they were willing to spend the money, it made a meaningful impact in their range. So yeah, first we've seen that. Just trying to think if there's anything else we need to cover here. I will say, you know, there's a lot of parts on the table. I hope you've had fun kind of bearing with us and checking out some of these. I will say, though, that we're really just scratching the surface in terms of the amount of data that we have and that we've collected about these units. We have motor reports where we go through and we've costed every single component you see here and even what you don't see. We have thermal management diagrams. We have pictures and weights and dimensions of all the parts, specifics on the magnets, specifics on the laminates. Everything that anyone could ever want to know about the motors, we have those available in reports. So if you'd like to go deeper, if you have any questions, if you're curious, please don't hesitate to reach out to us. Sales@leandesign.com. We'd love to get in touch with you and talk further there. The other thing I just wanted to mention as we kind of start to wind this down is we do have a Munro Live LinkedIn. If you guys are on LinkedIn and you would like to follow us, we're always putting links up to our videos and different content, fun things around the office. So if you want to stay in the know and know what's going on with us, please don't hesitate to subscribe to us there, follow us there. We'd appreciate that. And as always, we just appreciate you guys hanging out with us on Munro Live. So thanks so much. Hope it was useful. Have a great day, and we'll talk to you soon.